Quantum computing in India, Russia, and China. Executive summary. China, India, and Russia are all advancing in quantum computing, but at different stages. China leads with large-scale systems like the 504-qubit Tianyan and global quantum networks. India is rapidly building its ecosystem through the National Quantum Mission, startups like QPI-AI and QNU Labs, and partnerships with IBM. Russia focuses on defense, quantum sensing, and secure communication prototypes. All three view quantum technology as key to national security and future scientific leadership. Article: Quantum computing uses the principles of quantum physics to perform calculations that normal computers cannot easily handle. It could transform industries like medicine, finance, cybersecurity, and artificial intelligence. Many nations are racing to build this technology, viewing it as both a scientific and strategic priority. This overview compares the progress of India, China, and Russia, three countries developing quantum computing for national and commercial use. India. National strategy. India's National Quantum Mission, NQM, is an 8-year plan to advance quantum technologies. Its goal is to build intermediate-scale quantum computers with 50 to 1,000 qubits using different technologies, such as superconducting and photonic systems. The mission also funds thematic hubs that focus on hardware, software, communication, sensing, and materials research. These hubs connect universities, startups, and government laboratories across the country. Hardware development in India has made progress turning research into working systems. QPI-AI Indus, 25 qubits. In 2025, the Bengaluru startup QPI-AI launched India's first 25-qubit superconducting quantum computer, a full-stack system combining hardware, control, and software. IBM-Tata Partnership. IBM and Tata Consultancy Services plan to deploy a 156-qubit Heron processor at the new Quantum Valley Tech Park in Andhra Pradesh, expected to be the India's most powerful system. TIFR prototypes. Scientists at the Tata Institute of Fundamental Research have built 3 to 6 qubit superconducting chips in partnership with the DRDO. Quantum communication projects like Quantum Experiments using satellite technology, QUEST, have demonstrated quantum key distribution, QKD, over hundreds of meters, preparing for satellite-based networks. Early applications. India's most developed area is quantum cryptography. QNU Labs, based in Bengaluru, sells QKD devices, ARMOS, and quantum random number generators, TROPOS, to improve secure communications. Startups such as QPI-AI aim to open their systems to researchers and companies for testing hybrid quantum classical applications. Assessment: India has not yet achieved large-scale commercial use, but is building the right ecosystem. Strong government backing, technical training, startup growth, and international partnerships. Quantum secure communications are its nearest term success. China leads globally in both scale and integration of quantum technologies. It has built large-capacity quantum processors, national communication networks, and public cloud platforms. Hardware and achievements. Tianyan 504 qubits. China's Tianyan platform features a 504-qubit superconducting chip called Xiaohong, one of the most advanced quantum processors in the world. Origin Quantum's Tianji 4.0. This company created new control electronics that make large-scale systems more stable and easier to automate. Manufacturing expansion at Chinese facilities can now assemble multiple quantum systems at once. Quantum advantage. The Zhujiang photonic computer achieved quantum supremacy in Gaussian boson sampling, completing a task far faster than any classical machine. Practical experiments. China is actively testing real-world uses. A 72-qubit Origin Wukong computer was used to fine-tune a billion-parameter AI model, showing that quantum systems might improve learning efficiency. Teams have demonstrated small-scale cryptographic factoring and cipher analysis using quantum annealing. The Metis satellite enabled satellite-to-ground QKD, quantum teleportation, and even a 3,800-kilometer quantum link between Moscow and Urumqi. The Beijing-Shanghai Quantum Network connects cities with fiber optic QKD lines, forming a large-scale secure data network. Access and impact. The Tianyuan 504 machine is available through China Telecom's Quantum Cloud, allowing remote use by researchers and companies. Origin Quantum reports hundreds of thousands of quantum jobs run in areas such as finance, biomedicine, and fluid dynamics. China aims to make quantum computing accessible beyond specialized labs through better automation and national coordination. Evaluation. China's progress is the most advanced among the three, combining strong hardware, communication infrastructure, and large-scale experiments. However, many projects remain in research stages, and challenges like error correction and noise reduction still limit industrial deployment. Russia's quantum computing efforts are smaller but focused, emphasizing defense, sensing, and secure communication. National vision. The country's quantum computing roadmap sets goals for developing hardware, algorithms, and applications in materials, science, industry, and military technology. Russia also invests heavily in quantum sensing, such as precise atomic clocks and magnetometers, which have near-term defense and navigation value. Hardware progress. In 2024, Lomonosov Moscow State University and the Russian Quantum Center announced a 50-qubit neutral atom prototype, the country's largest quantum computer. Earlier projects developed 20-qubit ion trap systems and small superconducting processors. Russian engineers created sub-angstrom fabrication techniques with plus or minus 0.2 angstrom precision to produce more uniform superconducting qubits, a step toward better scalability. Early uses. Quantum communication is Russia's most practical application so far. Sberbank, one of Russia's largest banks, tested quantum-secured VPNs in Moscow using the BB84 QKD protocol. Rosatom, the state nuclear corporation, launched a quantum business accelerator to support startups in computing, communications, and sensing. Assessment. Russia's progress is real, but less transparent than others. Its hardware prototypes and communication tests show capability, but large-scale systems remain under development. The focus on sensing and security could lead to near-term advantages even without advanced quantum computers. Overall insights. 1. Quantum communication is the most mature field. All three countries are developing QKD to secure national data networks. 2. Hybrid quantum classical computing is an emerging focus, especially in China's AI experiments. 3. Error correction and stability remain global barriers to scaling up. 4. Government support drives progress. India's national quantum mission, China's state-led ecosystem, and Russia's defense programs all highlight the role of national strategy. Final perspective. Among the three, China leads in scale, technology, and integration. India is quickly building capacity and commercial momentum. Russia is progressing through specialized projects in sensing and secure communication. Each views quantum computing as vital to future scientific leadership and national security. As they continue to expand, these nations are shaping the global race toward practical quantum advantage.